DuPont has been working with us for a little while now. They brought some issues to our attention. DuPont is actually a manufacturer of materials for PV. For the PV industry, they don't actually make the panels themselves, but DuPont and their partners and industry stakeholders at all levels are looking at the value chain and looking at how to improve safety and performance of the PV products that are out there. We've had a number of dialogues with DuPont over the last year, and we actually have a cooperative research and development agreement in place with DuPont, so that legitimizes our relationship with a non-federal entity. And DuPont has shared some ideas with us on how to help the Army become an educated and sophisticated buyer of photovoltaic panels. So the other thing I want to add is that DuPont actually went to the Army's Energy Initiatives Task Force first, and the Navy as well, so they're working with a lot of different sectors in the federal government. The speakers are Eric Romano and Alex Bradley, and the last point that I'd like to make here is that there is a center of expertise, a renewable center of expertise within USACE. The Solar PV Center of Expertise was initiated in the fall of 2012, and John Parrish of Sacramento District is the chair, and Thomas Sessa of New York District is the co-chair. So we've been working with them and really trying to get the word out on this, and that's the purpose of this presentation. So I'll turn it over to DuPont. Thank you.
Frank, thank you very much. I'm Eric Romano, Strategic Marketing Manager for DuPont Photovoltaics, joined by colleague Alex Bradley. Thanks for attending, everyone, and we appreciate the opportunity.
Eric, can you speak up a little bit? We're having a hard time hearing you.
Thanks, Kelly. Yes. Is that better? Is that better, Kelly?
It's a little better, but speak.
Okay, I'll try to speak up. Thank you. So thank you, Frank, and thanks for everyone's attendance. We appreciate the opportunity to talk about some of our work as it relates to our focus of sustainable growth of PV and driving penetration of solar into the energy space. You may be wondering, why is that important to the U.S. Army? That work's important to the U.S. Army because the industry is trying to cross some chasms as it tries to achieve those objectives. One of them is moving from installing PV to actually effectively harvesting energy. Another is trying to reduce overall cost of systems while improving quality standards and practices. And these are things that the industry is challenged with. And we'll be reviewing that today as we focused on real performance of modules in the service environment and how that might impact your energy security, for example. I'll briefly provide some context for DuPont, talk about the risks inherent in a PV project, then we'll go over some of our technical work, and as Kelly said, close with a Q&A.
On the next slide, this is slide 2. Most people, as we were introduced, recognize DuPont as the leading material supplier to the PV industry. We are also an owner and end user of our own PV systems. On the left-hand side of this chart, you see a cross-section of the two different types of photovoltaic technologies, crystalline silicon on the left-hand side and thin film on the right-hand side. This not only shows where our materials go into a module, it also helps to explain the different components used in designing photovoltaic modules. On the right-hand side, when we look at some of our systems at DuPont manufacturing sites around the globe, it's important to recognize, just like I'm sure for many of your systems, there are many site-specific requirements, whether in some cases we use photovoltaics to maintain and achieve LEED Green building certifications. In some cases we have systems for technical analysis and training. And then other sites we use for truly distributed generation of electricity where the cost of electricity is very high, such as in Hawaii.
So this is Eric again. Let's start to look at the sort of morphology of a PV project, if you will. And first we'll look at kind of the objectives one is trying to achieve, and then we'll start looking at these over the frame of time. Achieving all the objectives of someone earning money, getting the power out of a system over a long period of time is very non-trivial. And the energy production, the financial performance when one is doing a PPA are not always aligned. So if we look at the financial performance side first, there's a lot of developer focus on incentives, taking the cash out through our interesting system in the United States. The off-taker payments, there's often performance insurance that backs up a warranty, and clearly potential warranty claims if there are in fact issues. What one has to remember is one does not get the electrons back, right? So if there are system issues, if the degradation is higher than predicted, and one wants a certain output from a system, it's challenging enough to get the financial performance one wants and actually achieve a warranty claim, for example, and we'll touch on that. But actually, you just don't get the electrons back. So folks that want to manage against a particular energy output need to be more careful in how they structure their projects and how they deal with the industry in that regard. Two examples we frame that people start with the same objectives and have very different outcomes. The example on the top is 24 schools in San Diego, California, with the objective of going with solar to reduce energy price and also get off the grid and have their own energy security. After 6 years, all 24 schools had the solar removed because of a defect that led to a safety issue. The same objective was held by the Sacramento Municipal Utility District in Northern California when they stated they wanted to do the same thing, actually do maybe a little more technical experimentation. It was the first 1 megawatt site in the world. They, however, took an extra step and specified the level of quality and the technology they were going to use. Those panels worked successfully for 28 plus years. We have many of them here in Wilmington. We're collaborating with SMUD on analyzing those panels. So the objectives were the same, the behaviors were different, and the outcomes were very different. If we look now across time in the PV, and we spend a lot of time up and down the value chain trying to understand this and understand performance risk, we find the industry spends a lot of its effort in the first 4 to 6 months of designing and installing the system and ensuring systems get financed. There's a lot of focus on off-taker credit and land worthiness and interconnection, all important issues. Very little focus on what's going to happen for 25 years when the system is performing. And remember that about 70% or so of all developers are that. They're pure play developers. Projects are likely to be resold, et cetera. So thinking the developer is going to somehow manage performance risk for 25 years is a little bit of a canary. In fact, Nellis Air Force Base project's been sold twice, and I think it's about 7 years old.
On the next slide, you can see some of the challenges and risks that solar modules will face in the service environment. There are multivariate stresses that operate on a solar module throughout its 25-year lifetime. The industry in some ways has done themselves a disservice in saying that solar has no moving parts. It has moving parts, those laminated structures, they just move very slowly over time. That's coefficient of thermal expansion. And recognizing that many of these stresses will be operating simultaneously on the module. In order to understand these stresses and what the challenges and risks are that impact the long-term performance of a PV system, you really have to take a step back and take a systems approach to understanding the performance of a system over its 25-year lifetime, recognizing again that there are many variables that can impact the performance. And what you see here is a fishbone diagram in which we start to call out the different variables that will impact the performance of the system over time. And we've begun to catalog and identify these degradation modes in order to mitigate the risk with control plans or improved testing methodology. And I'll begin to go through some of these in the interest of time. We won't hit all of those. Also provided you with a reference that shows and indicates there is no one test that can predict if a module will last 25 years, at least not until we understand all of the degradation modes, all of the acceleration factors, and have a fixed design. In the next slide, as we begin to identify and catalog the different degradation modes that were called out in the fishbone diagram, we can see that the bill of materials and design is one area of risk that we here at DuPont have a lot of familiarity with in terms of supplying the materials to the industry. What you see here is modules that have been in the service environment for less than 5 years that have been sent to us for analysis. The module on the left-hand side has the outer weatherable surface has cracked and delaminated, becoming a safety issue. The modules on the right-hand side, the inner layer of the backsheet has begun to yellow and discolor. The next degradation mode, when we look at installation errors, we can see the module on the left-hand side was a glass type of constructed module that had our ionomer encapsulant in it. A shim was placed between the frame and the glass, causing that glass to fracture on the back side. On the right is an example out of one of our own systems in which there was an extra hole being drilled through the module at the grounding bar, which penetrated the module and began to degrade the cell. Consistent manufacturing is very important as well. You can see here some examples of manufacturing issues. On the left-hand side, you see bent bus bars and misaligned cells. This is a safety issue as it can create an arc over time. On the right-hand side, you see the effects of non-uniform solder. This is a thermal image of a module showing hot spots at the solder bonds and interconnects.
So no one sets out to create PV systems and PV modules that aren't going to work, and that's particularly true of people that want to use or buy that energy. There are many assumptions that are made in the industry or misconceptions that lead to the results not meeting the expectations, and we'll touch on a couple of them. One of the biggest assumptions that made is a module, and we'll touch on that because as we have found in our fielded module work, that is definitely not true, and you've seen some examples. There's another major assumption we'll touch on, which is that module certification reduces risk. The certification tests essentially show that when you plug the module in, it's safe. They say very little about 30+ years or 25+ years of performance, and we'll talk a little bit about that as well. Touch on some of these things and take questions on others potentially.
The next slide shows why module choice has really become difficult, especially here in the United States. In the lower left-hand side, what you see was the seminal work performed by the Jet Propulsion Laboratory when they were contracted by the Department of Energy to optimize the design structure of a module in order for it to last 20 to 30 years. And what you see is as they go through the different design iterations, the bill of materials had moved to a fixed design that incorporated glass, EVA, and a Tedlar polyvinyl fluoride based backsheet. Currently in the industry, when we look at this slide and compare it to today, we say that the industry is actually decommoditized in the sense that now there are over 61 different module manufacturers with 900 different module designs according to Solar Pro magazine. The current industry situation now results in performance uncertainty and increased risk for developers and end consumers.
Some point risk at different geographies. Oh, it's because modules are made in China, and that really isn't the driving issue. There are several issues driving the behavior, but it's not specific to one geography. So we've seen issues in our fielded module work with modules from Japan, with modules from the United States, and with modules from China. And these are three examples, and we'll dive into one in more detail. One of the key issues the industry faces is, as Alex pointed out, there are no predictive tests for long-term performance. And as the module makers fight to survive in the economic situation they're in, they just don't have better tools than the certification tests when they're making material changes. And this is some of the results of those material changes that have on system developers and energy consumers. This is an example from our fielded module work. One of the first sort of experiments on materials actually had to do with backsheet change. Japan went to a 10-year feed-in tariff residential market. The Japanese module makers shifted from the JPL standard to polyester backsheets, and this is the results. We studied many modules, and here's a summary of what we found. We found some failing wet leakage, so safety issues. We also found higher levels of degradation as those materials degraded. Here we've plotted on the next slide the impacts of that. You see the module that was taken out of service after 12 years, energy went to zero, and the module with higher degradation, you see that curve of energy output as well as energy value. And you're talking about millions of dollars lost in that case to the developer, but electricity lost to the energy consumer. And again, these were all certified modules, and the expectation is they'd all perform at the green line. So it's all about knowing what you're getting yourself into. See if I just skipped a slide, I'm sorry. I don't know what we just skipped over.
As Eric mentioned, it's important to know what you're buying. There's a lot of variation in the bill of materials, and that variation will result in different performance of the modules in the service environment. And this is clearly an example of two different bills of materials performing differently in the service environment. On the right-hand side, you see one module that is turning yellow and the module adjacent to it not turning yellow. And it's clear also in the system on the left-hand side, two different types of weatherable materials being used in the same type of module.
If you can see this next slide, and we can't, essentially this slide speaks to the certification test not being predictive, and I'll talk through it very quickly in case you can see it. And if you can't, then you'll get hopefully the point of what we're saying. There was a study done in India comparing modules that had been IEC certified and modules that were not IEC certified, and that had no correlation to their long-term performance. In other words, the top performing modules, some were certified, some were not. There was just no correlation. Again, supporting from a technical point of view this point that the certification test is just not predictive. The next thing we wanted to touch on is as a potential PPA customer buying energy, it's good to know where the developers are coming from, if you will. And here's some work that from a survey of over 100 developers. How do they think about reliability? And it's something the industry is trying to deal with and grapple with, granted. So two different charts that show some interesting misunderstanding of reliability and really a lack of quality management 101, if you will. Is it more important to know who you're buying from or what's in what you're buying? Over 2/3 said it's more important to know what brand or who I'm buying from. Down lower in the survey, separated on purpose, would a standard BOM, bill of materials, help improve reliability? 93% said yes. So very inconsistent responses. The fact is there's no transparency now in the industry, and folks don't know what they're buying as materials change dramatically.
One way to mitigate both the design risk and the manufacturing inconsistency that we spoke of earlier, two prongs of that fishbone diagram, is to implement a control plan through fixed design and consistent manufacturing processes. We here at DuPont have been implementing that same mentality in our own systems and using our own systems to learn and provide a feedback loop for us. In addressing the design and the bill of materials, is appropriate to have a technical specification, and regarding the manufacturing, consistent manufacturing is important to ensure quality program such as ISO 9001.
So just to get more detailed on the best practices, these are examples of things that we've provided to the EITF as recommendations, some of which are being adopted, some of which we're still in discussions on, but on the left, best practices. We've talked about, again, this Quality Management 101, increasing transparency on module selection. So the solar industry is quite unique in that there really are no specifications, and there's no what we call conformity. So a module maker can have multiple bills of materials that all pass the safety test, basically, that we've shown have very different end-use outcomes. And we believe that both the developer and the energy consumer, if they're interested in energy security, should understand what that bill of materials is and make sure that what's provided conforms to what was quoted and chosen. Or in case of what we do and some developers are starting to do, you specify a bill of materials from proven materials and say, this is what I want to buy. We believe it's important to improve visibility of past performance of developers. The industry is developing in terms of really understanding performance and how things have worked or not worked. In the world of PV, 5 years is a very short amount of time. And the early drafts of contracts said, within 5 years report, average performance basically. We're saying look for best and worst, look outside 5 years, really get a better sense of how have those arrays really performed under the management of that developer. Finally, assess contractor experience and their plan for asset optimization and management. A lot of work going on in this area to improve. Frankly, many developers in the U.S. are relatively new to developing solar. It seems like a good financial incentive-driven area to get into, and they really aren't that good at what we call effectively harvesting energy, which is what you all need for this energy security. So we believe there needs to be some real effort put into assessing contractor performance as well as their plans for managing the assets. And most of that isn't typically listed or defined up front in a solar project. Post-award, we talk about validating, as we said, the conformance. We provided some potential forms one could use. Again, to us, this is sort of Quality Management 101. But also to us, the solar industry is a 40-plus-year-old, very nascent industry. It still behaves very nascently in spite of its kind of age, and it probably has to do with its growth rates, et cetera. So we've tried to provide some tools as well to the EITF as well as the U.S. Navy to consider using as you consider developers for your projects. And it's really about standing up the practices of the developers that you're choosing and working with and ensuring that they're using practices that you believe meet the needs that you have for energy security and energy output. We offer a tech service offering where we go out and visit people's arrays, existing arrays, and study them. We look at the modules with them. We can do that in situ with the modules on the arrays. We can jointly choose modules then to bring back to our lab here in Wilmington, Delaware, and really do deeper dives on. And this is what's opened the eyes of a lot of developers because many of them really aren't out visually assessing their arrays and what's really happening out there. And we've found a lot of issues, and it's helped people learn how to do these things better.
both pre and post installation to verify the bill of materials.
So in summary, we believe that proper materials selection really reduces performance risk. There are proven materials. We in the industry tend to know what works. You don't want to be the beta site test for unproven materials. And this is an asset that you want to produce energy for a very long period of time. A lot of people get in this industry and they say, okay, no moving parts. And I say, go stand outside in the desert for 25 years and see how that feels. It's a very demanding environment. And it's very difficult for that module system to perform for that period of time. And that's what folks are getting themselves into, and you want to know what you're getting yourself into. We've seen many examples of poor material choices. Again, nobody does that on purpose, but one has to understand the connection of system design to outcomes. There are some very simple actions that people can take. Again, to us, Quality Management 101. And we are working broadly across the industry on standards and other driving forces that will help the industry. And in the meantime, we're saying folks should take it upon themselves to minimize their performance risk and to know what you're buying. So now I think Kelly and Frank will open it up to questions.
Oh,
Thank you, Eric.
Or email
Q&A box.
either Frank Holcomb or myself.
Either Frank Holcomb or myself.
And I'll also add, if folks want to email Alex or myself any questions or call us, that would be fine as well. Let's hopefully get some Q&A here. But if you think of a question afterwards and want to reach out, we'd be very open to further dialogue.
Hey Eric, this is Frank. One thing maybe.
Eric, this is Frank.
One thing maybe you can talk about is warranties.
One thing maybe you can talk about is warranties.
Yes. So a couple things on warranties. So in general, what we say about warranties is they provide a good backstop. They're not, to us, the main risk mitigation tool. So a couple things we've found in our own experience on warranties. First, one has to realize that the warranties are written so that it's very difficult to get remuneration from a warranty. And I'll give two examples. One has to do with the fact that warranties are really only written to deal with complete module failure. And that's still about 0.1%. Modules don't fail that much, and that's a great thing. What modules do is they degrade at different rates, and getting remuneration for performance issues in a module is exceedingly difficult. We believe it's much easier to design or define what you want up front and define that up front and still have the warranty as a backstop, but not to depend on the warranty. I mean, remember, the marketing departments at the module makers write the warranties, not the technical guys. There's been very few longitudinal studies of real performance of modules.
Eric, can you see my question in the Q&A?
Eric, can you see my question in the Q&A?
No, I can't. Could you just read it?
So the question is, can you talk about specific?
So the question is, can you talk about specifications of work that you're doing?
Could you be more specific about that? We are working with both, I'll speak in general to that. We're working with end users, developers, and also some module manufacturers in order to help them define technical performance specifications to ensure that to reduce the uncertainty in the purchasing process. When we look at, as we've shown in the one slide, 900 different module specifications, we are working with through collaborations and joint developments to help minimize the risk and develop the appropriate technical specification to reduce the uncertainty.
Yeah, that was what I was looking for, Alex. Yeah, that was what I was looking for, Alex. But it's a very long process for some of these
And
standards.
we'd be happy to work with.
But it's a very long process for some of these standards.
Yes, because the standards take anywhere between 3 and 5 years. And in addition to that, the standards have to, understandably, have to be general because there are so many different types of technology out there. We work in one-on-one cases with, again, developers, end users, EPCs, etc., that want to move towards.
I'm gonna wear like yoga pants and a sweatshirt.
Proven
I'm gonna wear like yoga pants, sweatshirt.
God, you're ready. No doubt.
God,
you're ready. No doubt.
To help ensure that they get modules that they had specified and what they asked for.
One thing I would add to that, in addition to what Alex said, just to put a little more context on it, so as we go beyond that to actual performance kinds of tests, and we've written some papers on this in the industry, which we're happy to share, what we measure against is modules from the service environment. So in other words, we've got 30-year-old modules, 28-year-old modules, 26-year-old modules, et cetera, in our lab, and we accelerated age modules, and we compare the outcomes. And not many people are doing that. There's a cottage industry forming in terms of testing modules and beating them up. But in our view, if you're not trying to be predictive and correlating that to what's actually happening in the service environment, you're creating additional soft cost without improving your predictability, if you will. So, we're trying to work on true predictive tests. So that's the other time factor, Frank, around developing good sort of technical specifications and kind of performance testable type specs, but that's what we're working on as well. In the meantime, we're back at, quality management 101. Have the developers tell you what they've asked to buy and make sure they conform, what it is they purchased. As Alex said, with some developers that they've had issues, they want to go the next step, and we'll actually recommend both module makers and bills of materials that they should consider.
And I think you were working on some best practices documents.
Yes, and some of those we've disseminated both through our interactions with the government, and also in some of our public presentations that we've given at different conferences as well.
Alex, you might have already covered this, but we had a question from Doug Tillman on should there be a performance warranty?
A current warranty has two parts to it. One is workmanship, and the second is actually performance. So that does exist today.
And the challenge with that, and one has to remember with solar panels, it's a little unique in that they're tested at standard test conditions, right? So there's a lot of detail and a lot of funny games that go on relative to this. I won't get into all that, but at a general level, you test the module on a tabletop or a vertical flash tester, which was also developed by the Jet Propulsion Lab, by the way, and that creates the watts of the module. And then I take the module outside. So as I find degradation in the field, how am I confirming back that it in fact has degraded, and how do I prove that to the module maker and then get the warranty? So that's why There are performance warranties. It's getting remunerated for it, for those, that's extremely difficult. And most developers are starting to realize they're not getting remunerated. Most of them are written, you have to get to a certain level in 10 years, even if they're linear. So if you have in year 3 performance problems, what are you going to wait to year 10? I mean, again, warranties, these kinds of warranties tend to be written, so they're rather difficult to deal with.
The best warranty is the one that you don't have to use, is one of the sayings that we have. Additionally, a warranty doesn't produce electricity, a module does. So that's the approach that we've taken in our systems, is that you build it right, you build it once the first time.
Additional question from my team. Do you guys have any information about connecting into microgrids?
Do you guys have any information about connecting into microgrids?
No, we haven't focused on that. I would suggest following up with someone from Sandia National Laboratories. They're very well versed on integration to the grid. They have a division there called DETL, Distributed Energy Technical Laboratory, I believe is what it stands for, and they study how the solar systems integrate to the grid.
Great. Does anybody have any additional questions?
I'd like to make one comment, Lindsay. I'd like to make one comment, Lindsay. In our agreement with DuPont, they have offered to go out to some of the Army sites to look at some of the panels that are installed. I don't want to speak on behalf of DuPont, but that was probably an option.
Yeah, Frank, thank you. Certainly it is. And we learn from those interactions too. As I said, a lot of our work is driven by what's happening in the service environment. And that's the way we access that kind of data. So yeah, we do encourage those kind of interactions.
And we have unique analytical capabilities to measure both the materials.
Take them up on it.
And identify the materials used in the modules.
Just take them up on it.
As well as thermal imaging capabilities, and then here in our laboratories at our global headquarters in Wilmington, we have tremendous capabilities in terms of module material analysis. So we would be happy to work with anyone in that regard.
Did you read?
All right, where we don't have any additional questions, so if anybody wants to
All right, where we don't have any additional
write in or
questions,
email
so
me.
If anybody wants to write in or email me.
All right, well, I really appreciate your time, Frank, and the DuPont team.
All right, well, I really appreciate your time, Frank. And
So we have your contact information here,
Thank you very much, Kelly.
So we have your contact
and
information
I have
here.
this webinar being recorded. We'll have it on
And
the
I have this
Sustainability
webinar
Energy
being
website,
recorded. We'll have
so it
it
should be available within the next week. And I apologize again, everyone, for the feedback. There seems to be an issue with our network.
And I apologize
Frank and I
again,
are having
everyone,
a little
for
bit
the
of trouble
feedback.
with
There
that.
seems to be an
But
issue.
I think that the main point behind DuPont was well received. Thank you for your time.
I think that the main point behind DuPont was well received. Thank you for your time.
Thanks, Eric and Alex.
Thank you.
Thank you.